All good? Okay. So hi everyone, thanks a lot for coming. Today I'm going to talk to you a little bit about and gather some thoughts around ZK proofs and oracles. So yeah, maybe first if you can just raise your hand if you're familiar with oracles first. Yeah, okay, great. And raise your hand if you're familiar with maybe Starknet. Okay, a few. Okay. So yeah, basically I just want to have a first disclaimer around ZK proofs. Most of the time when people are talking about ZK proofs, in fact, it's validity proofs. So when you're talking about ZK rollups, in fact, it's more validity rollups because validity rollups are not using the privacy part of ZK proofs. It's using only the scalability part. So actually, the talk was about ZK and oracles, but it's more about validity proofs and oracle. So yeah, that's just a first disclaimer. Now let's move on to the oracle problem, and we're going to try to see what validity proofs and so ZK proofs can change to the oracle problem. Basically, the oracle problem is how can we access external data on-chain. So we have a blockchain that is trustless, unstoppable, transparent. So it depends on which blockchain we're talking about, but most of them are trying to achieve those properties. And so when we are trying to access data, it's more complicated because it's pretty complicated to deal with off-chain sources. How can we have systems that bridge external data in a trustless, unstoppable, and transparent way? And so that's the oracle problem. There's a bunch of oracles that are trying to solve this problem with a different approach. And so yeah, I'm going to try to explain what validity proofs and ZK proofs are bringing to this equation and how we can better solve the oracle problem with validity proofs. So can validity proofs solve the oracle problem? The short answer is it cannot solve the entire problem, but we can remove some vectors of attack in the oracle design. So basically what ZK proofs and validity proofs are achieving, the goal of validity proofs is to achieve trustlessness without decentralization. Basically, blockchains were created to have this trustless system where you can run program in a trustless way. But ZK proofs just completely changed this problem. Before, to have something with trustlessness, you had to have decentralization and enough validators so that you could say that everything that you're computing on-chain is trustless. Now with ZK proofs, it's just math that are proving that some computation, some piece of code actually run in the right way. So it's completely changing our vision on trustlessness. And basically for most of the problems that decentralized applications were trying to solve. So I put a tweet of someone well known in the Starknet ecosystem, which is Sylv. And basically most of what we're trying to do in the blockchain space is having this trustlessness. But now with ZK proofs, we are not forced to put everything on-chain. Because we have those validity proofs, we can just get the trustlessness from those validity proofs. So that's what validity proofs are changing in the equation. And so in terms of oracle and what it solves in terms of oracle, basically the answer is we now have access to trustless computation. So we can have a lot of computation on top of raw data that is trustless. So it's proven with validity proofs. And we can get the transparency we didn't have from off-chain systems that are currently in production for oracles. So that's the two main points. Now, what it doesn't solve for the oracle problem is mainly the quality of the data. And so also the liveness and how unstoppable the system is. So trustlessness doesn't mean that you're going to have a result on your decentralized application. Trustlessness means that if you have something for your app, if you get a piece of data, it's going to be the right piece of data and the computation is proven. But it doesn't mean that you will get this. So we don't have liveness, and on the data quality, we have trustless computation, but the problem is we still have the problem of data quality, meaning that we can perform a lot of computation, but we have to make sure that the data we are working on, and so the computation which is happening on the data, so we have to verify that the data is of high quality. And so that's, so we reduced a lot the attack vectors. So we removed all the assumptions on the computation and also brought a lot of transparency, but we still don't have those true properties. And so yeah, I'm just going to go through, well, there's a little problem with the title, but yeah, anyway. Yeah, exactly. So yeah, how do we solve the two problems I talked before? So how do we get data of high quality, and how do we get the liveness we don't get with validity proofs? For the data quality, the short answer is game theory. So we have to ensure that data providers and people providing data to the network are incentivized to give the right piece of data and are not trying to manipulate those pieces of data. So the answer to this problem is game theory. And in terms of liveness, so it's pretty much the same problem as the problems that are having ZK rollups right now, meaning that we have to decentralize the sequencing and how we pick up transactions and sequence them. So we have to build still a proof of stake to get the liveness property. So that's how we can solve the two problems before. Now I'm just going to go through what it means in terms of game theory for the quality of the data and the key properties we need to have in order to make sure that the data is not manipulated and of good quality. So the first point is about having as much sources as we can, and so decentralizing the different data providers. And so those people that are providing data needs to be incentivized to give the right piece of data and needs also to be punished if they're trying to manipulate data. So that's the two first really important points, because right now, if you're thinking about different Oracle solutions, they're not especially those properties. And the final one is we need to make sure that data providers are not cooperating to manipulate the price. So that's basically how you can make sure that the data you get is of high quality. Okay, still a bad title. Then how you make sure that you're decentralized enough to provide the liveness of the Oracle. And basically it's in two parts, mainly providing liveness for the sequencing and providing liveness for the proving layer. For the sequencing layer, it's basically pretty simple. It's like a proof of stake, a classic proof of stake. You can So you have different systems, but it's already a lot studied. This type of architecture is already a lot studied. But for the proving layer and how you prove the consensus and how you prove the execution of your computation, it's a more complex problem because it's we're just at the very beginning of ZK proofs, but there's already a lot of work in this area and how to ensure that everything is proven. Now, if I can just talk a little bit about Pragma. So, as you imagine, oh, okay. So, so I'm going to pretty much explain the use cases and why it makes a lot of sense to incorporate validity proofs in an Oracle system. Is basically you will get a lot of computation that you don't have with classic software, classic oracles. Basically, the property of validity proofs is that you can verify them in logarithm complexity. So it's way easier to verify ZK proofs than just verifying all the computation that happened. And so with that, we get a lot of computation. And if you're thinking about TradFi and basically how TradFi is running today, most of the systems are not running on simple price assets. You can think about it, but there's a lot of risk parameters, volatility factors that actually need computation to be there. And so we can have a lot more pieces of data available for DeFi applications thanks to validity proofs. And all this computation doesn't introduce any more trust assumptions because it's trustless. So for instance, you can think about basic volatility, so realized volatility. You can think about how you compute the price of options, for instance, how you compute Black-Scholes, implied volatility feeds, how you parameterize different volatility surfaces, and everything, all that kind of data needs a lot of computation, and that's only doable thanks to validity proofs. So that's what trustless computation and validity proofs brings to oracles. So yeah, I think I don't have a lot of time left. So yeah, that's pretty much it. If you want to, okay, yeah, great. Yeah, so we're I just wanted to say a few words. We're organizing a big hackathon around the StarkNet ecosystem, and so Cairo 1, which is the programming language of StarkNet. We are organizing this bigger hackathon with more than $80,000 of prize pool for the participants. So it's going to happen online at the end of June. So I invite you to check our website and social media to get connected for this hackathon. If you want to get involved in the StarkNet ecosystem, learn more about Stark Proofs and KO, which is the general purpose programming language of StarkNet. So yeah, I invite you to check it out. And I think I have some time to answer questions. So happy to take them if you have some questions.
Yes, thank you, Mattéo.